So today's our last day of transformations. We do have a demo today. I'm going to go over the summary of the previous class, and we'll do the demo for today to sort of summarize everything. And then your class activities for today are learning how to apply multiple transformations to a function. So hopefully at the end of class today, you'll leave feeling like you have a grasp of how the rules of transformations work. Next class, I'm going to give you your next take-home quiz, quiz 2, and that will be due on Monday, just so you have an idea of what's coming up. Not till Friday. Yeah, Friday I'll hand out the quiz. It's due Monday. All right, so I'm just going to backtrack a little bit here to the summary of class 15, so what you should have finished coming into today. All right, so again, just like with our previous summary, if you didn't work through all of the activities, these conclusions might feel like, why, right? You have to work through the activities to see the why of it. But this is the summary of all the rules, okay? So if f of x is our basic graph, c is going to be some positive real number. If we transform f by multiplying c times f of x, is that a stretch or a shrink, and is it vertical or horizontal? It's vertical because it's outside of the parentheses, right? F of x is just a fancy name for y. So you're doing c times y, which is going to be a vertical change because you're changing the y value. And is it a stretch or a shrink? It's a stretch. Yep. Oh, sorry. So it depends on the size of c, right? Depends on the size of c. If c is a big number, like bigger than 1, then it's a stretch. By multiplying each of the y coordinates by a factor of c. Good. If c is a small number, like a fraction, a half or a third or 0.2, right, then this is a vertical shrink. Vertical shrink. You multiply by a small number, things get smaller, right? So vertical things are always exactly intuitive. And you're going to do that by multiplying each of the y coordinates by a factor of c, right? C is already a small number. You multiply by c, things get smaller. What happens if c is negative? Yes. Then the graph of f of x reflects over the x-axis. Good. All right, here's where it gets weird. Just like with our shifting rules, when the change is to the x value, inside the parentheses, so you're changing x, it's definitely going to be a horizontal change, right? Because we're changing x. But anytime you're changing x, you're changing things horizontally. The change is opposite of what your intuition says. So if c is bigger than 1, you're multiplying by x by a big number. You would think that things would get bigger, right? But in fact, they get smaller, right, when it's a horizontal change. So when c is bigger than 1, then f of x shrinks horizontally. Okay. And you shrink it by dividing each x coordinate by c, right, as opposed to multiplying by c. Or you can think of it as multiplying each x coordinate by 1 over c. Same thing. If c is a tiny number, like a half or a third or 0.2, right, a number between 0 and 1, when you multiply x by a small number, you'd think that all the x's would get smaller, right? But they don't. They get bigger, and the graph ends up stretching horizontally. Stretches by dividing each of the x coordinates by c, because dividing by a small number makes things bigger, or multiplying the x coordinates by 1 over c. Same thing. And what happens if C is negative? It reflects over the y-axis. Good. Okay, so if we jump to today's preview exercises, we're going to be applying that summary, right? So I have this piecewise graph, A, B, C, D, and E are the important points. And I want to sketch a transformation G of X, which is 3 times f of 2x. Okay. So let's see, my 5 key points are A, B, C, D, and E. So A, I'm just going to label their coordinates first. A is -6, 5. B is -2, 1. C is 0, 7. D is 2, 3. And E is 4, 5. All right, so I want to transform the x coordinate. So I'm trying to graph 3 times f of 2x. I'm just going to write that down here. G of x is 3 times f of 2x. All right, so that 3, is that the vertical or a horizontal change? Vertical, because it's outside of f. So to transform my y coordinates, you just do exactly what you'd think, multiply by 3. So you're going to take your y times 3, right? Now, the 2 that's inside with the x, that's going to be a horizontal change, which means I'm changing the x coordinate. But how am I going to change the x coordinate? Divide by 2. So I got to take the x coordinate and divide it by 2. Yeah, it's like the opposite of what you think, right? So that way my x coordinates will shrink. All right, so to transform my x coordinates, I have to divide them all by 2. So I get -3, -1, 0, 1, and 2. To transform my y coordinates, I have to multiply them all by 3. So I get 15, 3, 21, 9, and 15. So then my final points are just the new x and the new y. -3, 15, -1, 3, 0, 21, 1, 9, and 2, 15. So I'm going to plot those. -3, 15, -1, 3, 0, 21, 1, 9, and 2, 15. 1, 9, 2, 15. I'm going to connect those. So you can see graphically what happened to my graph is that there was a horizontal shrink, right, and a vertical stretch. Did I do it all right? Yeah, that's right. So it's compressed horizontally and stretched vertically. Let's look at the domain and range of each of these things. The length of the domain of f and the length of the domain of g. So let's see, the domain of f, my original graph, its domain was -6 to 4. Those are the x values it lives on. And then what's the domain of g once I transformed it? -3 to 2. Yes, -3 to 2. Okay. So what's the length of -6 to 4? How long is that? 10. The length of -3 to 2? 5. Compare them. Halved, right? Right. So my domain was halved. That was the effect of the 2 in here. Right? My horizontal shrink, it halved the domain, it compressed everything. Okay, so length is 10, this length is 5, and it's half, right? Domain was halved or divided by 2, right? All right, let's look at the range. The range of f. Smallest y value is 1, biggest is 7. Okay, 1 to 7. And then the range of g. The smallest y value on g is a 3, and the biggest is a 21, 3 to 21. Okay, what's the length of the range of f? 6. 1 to 7, there's 6 units in between there. How about in g? The length is 18. How are 6 and 18 related? Times 3, right? That's what the 3 did out here. I tripled my range, my vertical stretch. So the range tripled. Okay, so let's summarize our 2 days of transformations now. Summary of all our rules. So if f of x is our basic or our parent function, there are 4 transformations I can do. I've just put in generic letters A, B, C, and D here instead of numbers. So you can have A times f of B times x plus C plus D. Which of the constants A, B, C, and D move the function around, shift it in the plane? C and D. Addition or subtraction moves the thing around in the plane. So that would be C and D. Okay. Which of the constants change the shape of the function by pulling on it or compressing it? A and B. Multiplication stretches and shrinks the shape, right? Which of the constants affect the graph horizontally, whether it's by moving it or changing its shape? C and B, the ones that are changing x inside f. Yep, so B and C. Those are horizontal changes because they're affecting x. Which of the constants affect the graph vertically? A and D. A will stretch it vertically, D will shift it vertically. But both of those constants are outside of f, which means that they change f vertically. Okay, constants that change the graph horizontally, counterintuitive. Constants that change the graph vertically, exactly as you expect. So B and C were horizontal, and they are typically counterintuitive, right? Once you work through some of the activities, hopefully you'll see like why that counterintuitive thing happens. But then A and D, those are vertical. Those constants change things vertically. And this is as expected, right? Always works just as expected. All right, my only rule, if you're doing multiple transformations to a graph, the only rule is that you have to first change the shape of the graph, both vertically and horizontally. Do any stretching and shrinking first, then do your shifting. Be careful. Your book gives you a different rule for how to do the order of transformations. Ignore your book / MyMathLab's directions for the order of how to do multiple transformations. The order presented in class that we just talked about will better prepare you for Math 108 and Math 151 than your book's method. The 2 methods are completely equivalent, but ours requires the function's input to be in factored form. So I have this B factored out. Your book would have this as where they distribute that B, and it just looks a little more complicated because then you have to, this number isn't just the plain old C, it's not just your horizontal shift. You have to factor out the B first. So make sure that that B is factored out. In fact, I didn't give you any problems where it's not factored out, so you should be all set. All right, so those are the transformation rules. It took us 2 days to figure them all out, but that's what they are. And now you're going to work through class activities where you apply them in lots of different ways.